Hello guys, in this second part of the logic tutorial series, I'm gonna teach you about terminology. I don't know how many terms are going to be in this video. It basically is just gonna be whatever I feel like. So the first two terms you should know about is synced and unsynced. This is a unsynced thing. You see that there's delay between each of the cells. Is because you are wiring them directly. And a synced array is like that. Everything's instant. It's good for precise timings like making a CPU or GPU. Another example of synced and desynced is adders. Adders use a different terminology called ripple, which this would be considered ripple. And this one, which I got off the workshop, since I don't really know how to create one, and I'm probably going to create one someday, but it's not going to be today. What? How did I paste two? I thought I only pasted one. Anyways. This is called carry look ahead, which basically is the fancier term of synced. So the carry out, which is here, this is the carry out in my design, goes into the carry in, so it does this ripple thing, but here instead of just going directly in, it has logic in front, so it just instantly does it. Well, not exactly instantly. It still has some delay, but not as bad as of delay as this. Two other terminologies to know are ROM, which is read-only memory, which this is here. You only can read it. There's no way to write to it. And then there's RAM, which is random access memory. It's a type of memory where it can access anytime you want to. CPU means central processing unit, which this whole entire thing is a CPU except for the RAM. The RAM is its own thing, but this is kind of like a CPU controller or a computer controller. This is the ALU, which arithmetic logic unit. It does all the logic. And then two terminology that I use often is linear and perpendicular. Linear is like this ripples, like it ripples through, and then parallel. Linear and then parallel is when it goes to all the functions at once and then you choose the function. The reason why it's useful to have this is because I don't think you're going to use add and subtract at the same exact time. That would be weird. Or you would have bit shift left and bit shift right at the same time. And also, bit shift is like when you shift the bits, which this is to the left, as you can see, and then this is to the right. Oh, oh, that's B. And then that's A. This is another example of something that you want to be in parallel, because if you have it in sequence, it's kind of just going to like duplicate the digit. Excuse me, what are you doing? Why is that happening? I think is that the reason why? That has to be the reason why it's not working. Oh boy. I have to fix the area yet again. Creating this was such a troublemaker. I seriously did not like creating this. It's messy. Anyways, some other basic stuff, as you would see here. INV is invert. All is allow. In is basically input. +1, plus -1. I did them reverse. Bit shift R. Or you can call it BS. Just bullshit. Because it's BS to create. And then, yeah. My rat's nest brain segment. Function go. And then stop the computer. I don't know, that's probably everything. Yeah, that's everything. Oh no. Bit order. Least significant bit is like here 1, and then most significant bit is 8 in this example. So if I were to tap this, it would move it up by 1, and if I were to tap this, it would move it up by 8. I think that's all. So I don't know what else to do, so see ya.